Have you ever really thought about how computers shape our world? They're not just tools. They're the invisible engines powering almost every part of our daily lives from the moment we wake up to the time we go to sleep. From your phone that wakes you up in the morning, to the servers streaming your favorite shows at night, computers are everywhere. They connect us, entertain us, and help us work and play in ways that were unimaginable just a few decades ago. They help us learn new things, create art and music, and solve problems once thought impossible. Whether you're a student, an artist, or a scientist, computers open up worlds of possibility and creativity. The story of computing is one of humanity's greatest adventures, starting with room-sized machines that filled entire buildings, and evolving into sleek devices millions of times more powerful that fit right in your pocket or on your wrist. All of this progress comes from our understanding of electricity and information, using simple on and off signals or bits to build a vast digital universe. Every photo, message, and video is made possible by these tiny electrical pulses. But now, we're on the verge of another leap: quantum computing, based on the strange and fascinating rules of quantum mechanics. This new technology could change what we think is possible all over again. Quantum computers promise to solve problems that even today's fastest supercomputers can't touch, opening doors to discoveries in science, medicine, and beyond. So, let's dive in and explore how classical computers work, and why quantum computers could change everything we know about technology and the future. Get ready. Things are about to get really interesting, and you're about to see just how cool computers truly are. Let's start with classical computers. The ones you find in your phone, your car, and even your microwave. These incredible machines are woven into the fabric of our daily lives, quietly powering the technology we rely on every single day, often without us even noticing. At their core, classical computers process information using bits. Think of bits as tiny switches that can be either on, 1, or off, 0, just like a light switch. This simple idea is the foundation of all digital technology. Billions of these bits, called transistors, are packed onto silicon chips smaller than your fingernail. These transistors flip on and off at lightning speed, performing calculations and storing data, making everything from texting to streaming possible. Everything your computer does, displaying text, playing videos, sending messages, or running apps, breaks down into sequences of zeros and ones. This is how computers understand and process information. It's a binary language, and it forms the foundation of our entire digital world. Every website, photo, and song is ultimately just a pattern of these two numbers. Classical computers are masters of logic and precision, following instructions step by step at incredible speed. They can solve problems, analyze data, and automate tasks with remarkable accuracy. They're perfect for everyday tasks like browsing the web, writing documents, editing photos, and playing games with friends or family. But even these powerful machines have limits. Sometimes they freeze, crash, or just can't keep up with the complexity of certain problems. Some problems are just too complex, no matter how fast you go or how many computers you use. These challenges can stump even the most advanced classical computers. That's where quantum computing comes in, offering a new way to tackle problems that were once thought impossible for machines to solve. Now, let's dive into quantum computing, the wild side of technology. Instead of bits, quantum computers use qubits, which can be both 0 and 1 at the same time, thanks to a property called superposition. Imagine a spinning coin. While it's in the air, it's both heads and tails. That's a qubit. Qubits can also be entangled, linked so that the state of one instantly affects the other, no matter how far apart they are. Superposition lets quantum computers explore many possibilities at once. Entanglement allows qubits to work together in ways classical bits never could. This means quantum computers can tackle problems that are impossible for classical machines. It's not just about speed, it's a whole new way of thinking. Welcome to the quantum world. Let's compare classical and quantum computers using a simple analogy, a maze. Imagine you're standing at the entrance, searching for the exit hidden somewhere deep inside. The way you approach this challenge reveals a lot about how these two types of computers work. A classical computer tries every path one by one, methodical but slow for huge mazes. It's like walking down each corridor, hitting dead ends and backtracking until you finally stumble upon the solution. This process can take a long time as the maze grows larger and more complex. A quantum computer using superposition explores all paths at once, like water flowing through every route simultaneously. Instead of being limited to one path at a time, it spreads out, touching every possible solution in parallel. The first drop to exit shows the solution. It's as if the answer emerges instantly from the maze, no matter how complicated it is. With just a few qubits, a quantum computer can represent more possibilities than a classical computer with millions of bits. Each qubit doubles the number of states the computer can process at once, making it incredibly powerful for certain tasks. Classical computers grow linearly, double the bits, double the power. Their progress is steady, but it can't keep up with the explosive growth of quantum systems. Quantum computers grow exponentially. Add one qubit, and you double the computational space. This means their potential increases at a staggering rate with each new qubit. That's why quantum computers aren't for checking email. They're for solving problems with staggering complexity. They're built for tasks that would take classical computers thousands of years to solve. They're designed for challenges where exploring a vast landscape of possibilities is the key. From simulating molecules to optimizing massive networks, quantum computers open new frontiers. It's a game changer for science, engineering, and beyond. The impact will ripple through industries, transforming what's possible. The future of computing is exponential, and quantum technology is leading the way into a new era of discovery. Quantum computers are real. They exist in labs at companies like Google and IBM. They're not on your desk yet. They need extreme conditions to work, but scientists are already using them to tackle tough problems. In medicine and materials science, quantum computers can simulate molecules, something classical computers struggle with. This could speed up drug discovery and create revolutionary new materials. Quantum computers also excel at optimization, finding the best solution among countless options, like delivery routes or flight schedules. Even finance could be transformed, with better models for markets and risk. We're in the early days, but the potential is immense. Quantum computing could supercharge artificial intelligence, helping AI learn faster and spot patterns classical computers miss. But there's a challenge. Quantum computers could break today's encryption, threatening digital security. That's why scientists are racing to develop quantum-resistant cryptography, new locks for a new era. This cycle of discovery and challenge drives innovation forward. Beyond AI and security, quantum computers could revolutionize clean energy, brain research, and even the search for life on other planets. We're just beginning to imagine what's possible. By harnessing the universe's fundamental laws, we're unlocking new tools for humanity's biggest challenges. The future isn't just digital, it's quantum. Science keeps pushing the boundaries. The next breakthroughs are just around the corner. So, why should you care about quantum computing? Understanding this revolution matters for everyone. It's about the future of medicine, energy, communication, and security. Think of the early internet. Few imagined how it would change everything. Quantum computing is at a similar stage. Its impact will be profound, shaping solutions for climate change, disease, and more. Knowing the basics empowers you to join important conversations about funding, ethics, and security. It's about being scientifically literate in a world driven by technology. Learning about quantum computing is an exercise in wonder. It shows us the universe is stranger and more powerful than we imagine. Stay curious and you'll be ready for the future, whether it's powered by classical bits or quantum qubits. Science is for everyone.